to be here. I'll try to talk as clearly as I can because English is my second language. But yeah, I will guide you through a presentation on mapping for community and community development. If at any point of my presentation you can't hear me or I start freezing, let me know, please, because I'm currently in Italy, so I don't have as much as a connection as I would like. But let's get started. I don't know if the meeting is being recorded. Is
Yes.
it?
Yeah, yeah, it's
It is.
recorded.
Okay, good. Thank you. Okay, so as the host has very warmly introduced the topic for my webinar on this Regional Ambassadors webinar series, I'll be trying to share with you how I've experienced mapping for community and community development. I am a regional ambassador. I have been a regional ambassador since 2021, but I'm now working with community building and community development. And what I'm doing is helping chapters in Latin America to improve well, I'm from Mexico and El Salvador in Latin America, but I'm currently in Italy. And that's very much my introduction. So, what's the content for this session? It will be a very brief session, and I would like to read your comments in the chat. So I know what's your idea, what do you think of what I'm presenting. But generally, the content will be what do we understand by community development, because then we can better interpret and set our projects. Then we will kind of discuss and taking from the presentations from yesterday, how to map, what tools and methodologies we can use for our projects, and finally, some examples in Latin America, because I think it's easier to envision your methodologies and your tools and GIS in general when you have clear examples of what you can achieve with these actions. So, what is community development? I guess you can interpret it depending on your background, depending on what you've done so far, on your knowledge and experiences. But I think it's very important to set the community at the core of this idea. And by community, I don't mean enterprises generally. I mean more of the inhabitants of a place, inhabitants of a municipality, of a region, of a town, and organized people who can clearly identify the needs of their surroundings and who want to change the issues that they are facing. And regarding development, I think it's good to define community development within three scopes. So the first one is the need for localized activities. What I mean by this is that the activities, the projects, the workshops that we have need to have a specific geographic scale and scope. So what will I impact with my project? Will I impact the street that I live in? Will I impact my university, the town where I grew up, a municipality, and a region? And what does it mean with each of these geographic scales? Because depending on the size of your surroundings, that's what you will have to do in order to achieve your goals. And the other one is a needs for a community up focus, because I believe that activities and initiatives need to be born within the community's needs and interests. Otherwise, it's just them answering to another person's or another stakeholder's interest. And it's not really responding to the issues or the needs that the community and the inhabitants have. And the third one, it's a range of impact. It's very important to understand how our actions have consequences as well as they can influence our surroundings. What I mean by consequences is when you put someone who's maybe already exposed to violence or to insecurity and you put them on a map, it can have consequences on their life and it can have a negative impact. And it can work the other way around. Maybe what you need is to map all the buildings in your area, because then you will know how to better respond to floods or to a hurricane. And that will positively impact your surroundings. But it's very important to have both ideas and both results clearly identified, because in that way we are controlling more the the outcomes of our actions. So if we understand then what community development means in terms of improving the conditions that we currently live in, whether it's environmental conditions or social conditions, economic conditions, infrastructure conditions, then we can start to imagine how to approach, how to map, how to respond to those issues. And a disclaimer, something very important to always keep in mind, is that I can present you here with a methodology and the tools and some proposals, but it will always depend, and you will always have to make a decision based on your surroundings. That means the territory, the space, the conditions, the physical elements, and the community. So where are you? You need to ask yourself, what type of environment am I standing in? Is it a hot place? Is it a place on the coast? Is it a place with a forest? Because all these characteristics will have a different meaning depending on where you're at. Is it an urban or a rural place? Does it affect the accessibility of internet? Does it affect the accessibility of my phone and having to map on with using GIS? Maybe this will clearly affect and this will clearly influence whether you can map remotely or if the best decision is to map on site with paper and a pen and other elements. And the last question that we must ask ourselves is the level of participation within our community, because we might have the idea to propose a project or propose an activity, but maybe the community doesn't respond as we would expect them to, and that would make it very difficult to complete the idea and to have the impact that we wanted. So these are all initial questions that we need to ask. And an example that I would like to discuss throughout the session to explain and to better envision what I mean is, let's say you want to improve your streets infrastructure. Why? Because there are no ramps, there's no shadows for walking on the street, and when it gets hot, it's very uncomfortable for the population. And there are no walking sites for pedestrians. We can imagine that, and maybe we can even see it in our surroundings. So what does it mean by environment? I mean in a street. And I have to identify the elements and the characteristics of a street. Is a street completely made out of cement, or is it made out of any other material? Is a street in an urban settlement, or is it more of a rural? And what does it mean that it is more on the urban side? Is it connected? Is it a main street? Is it only a residential one? And on the accessibility levels, will I be able to obtain the information I want from this street? And will my neighbors want me to map the street? Will they participate in the mapping? How can I better make them participate? Do I need to do a campaign for communicating these issues that I've found? Usually, if it's a generalized problem, the community, the neighbors, the inhabitants, the government is very well aware that these issues need to be resolved. So it's just a matter, usually it's a matter of you presenting this idea in a very organized and clear way, so it's easier to act on it. So let's say I've identified my street's characteristics. I know that it's in an urban space. I know that it's only a residential street. I know that it has issues with a lack or a non-existence of ramps, that it needs to have trees so I can have some shadow to help pedestrians, and that I need walkable spaces. So those are the issues that I've identified. And also my neighbors said that they would like to participate. So now we have to move on to the point of how are we going to improve the information that we have in order to plan and in order to have actions towards improving the street. So we have to envision how we can change this reality. If there is no information of my street, then maybe the best way would be to map out the entire characteristics of the selected area and provide a duration, a time, a chronology to have my activities. So it would be a short-term project because I've defined that the area of study is very small. And it would be a series of activities. I can do workshops, and I can do a communication campaign, and we can do field mapping with my neighbors using one of the apps that we've already discussed in the past webinars. And with this characteristics, with these things already clear, I can start thinking about the objectives. My main objective would be to achieve an improvement in the street. So I can map out, I can organize with my neighbors, and we can go to the local authority to present the issues that we've identified, so they can start making these improvements. And we have to think about these tools that we have mentioned several times, and the extent that we can use these tools in order to achieve our goals. So what tools have the other ambassadors presented? I've identified two types of general tools. So we have the mostly remotely mapping, and we have the remotely and on-field or field mapping. And for this type of activity that we want to carry with our community, it would be better to have an on-the-field mapping, because you can better identify the surroundings. But just to go over them once again, if someone missed this information, on the remotely type of tools that we can use, there are the tasking managers, and they provide an assistance for volunteers to choose each task that they want to map and organize people in different countries and regions for humanitarian reasons or for development reasons. And on the field mapping, we could use Kargbo Collect for mapping out the trees that we have. We can use Mapillary for taking the pictures of the sidewalks that we have on the street, or where there needs to be improvement of the sidewalks. We can map on organic maps, and we can draft on field papers and then upload our information to OSM. There are a range and a possibility of tools that we can use in order to achieve the goal of improving the street that you live in. And all of this sounds very interesting, but it's very abstract, and we need to look at examples that allow us to better understand and to better plan our future projects. So I wanted to present you with 3 activities that we've done in Latin America this year, and talk about some of the things that we did, the methodology we used, and the results we had. The first one is a series of workshops that we had in Guatemala City, in Guatemala, during July 2023. So we presented OSM, we presented YouthMappers, we presented Kargbo Collect to university students, regional organization workers, and state workers, in order for them to start opening their information, because most of their information wasn't updated. And what we did was we collected data of schools on the field within a specific part of Guatemala City. And you can see the picture here. We had our printed maps, and we each had forms with Kargbo Collect in order to map out the schools that we needed to identify. And the results, well, we had about 15 schools or 10 schools, I cannot remember, and several places like stores around the area that would later be implemented and used within the National Institute of Geography in Guatemala. Another important example that I wanted to present today, that it's not so GIS related, but still is very important for us as a chapter, is a session on participatory mapping with high school students. So what we did was that we printed out different sectors of the municipality that our school and the high school students center was at. And each student made a group, and with stickers and colors and markers, they identified places that were sad for them, or that were very violent, or a place to relax or to go walking after classes, because it's very important also to attach meaning to the places that we add to the map, since we live in them. It's not just an imaginary space that you can see on a satellite imagery. It's also a place where people live, and they make and they are happy or they are stressed. So we recognized their experiences in the surrounding area of the school. We knew how they felt with their daily routine of getting to the center. And we promoted this dialogue to understand the importance of mapping, of community mapping. It's good, it's great to have the opportunity to remote map every single day, to get together online and to map with satellite imagery, but it's also necessary to acknowledge that people live in the places that we're mapping at, and that usually we forget about their experiences. So it's always important to do these types of exercises. And the last example that's very rich in content was an exchange among chapter members of different universities. So there were students from Mexico, from Colombia, from two different chapters, and they got together in Bogota, Colombia in June 2023. They conducted several activities because one of them lived in a municipality called Mosquera, and they realized that it wasn't mapped at all. So what they did was they organized with the local OSM community. They took aerial pictures with a drone because it had more details, so they could map in the tasking manager. Then they went to the site again to do some mapping with inhabitants and with students, so they could add it to OSM, like the stores, and they did validation at the same time by creating notes with people who knew the municipality online. So we have a project that took about 2 weeks to execute, but about a month to prepare. And we used different methodologies that looked or that expected to create a better sense of the municipality's infrastructure. And well, the results was that we mapped the entire, well, they mapped the entire center of the city of Mosquera. They also chatted, they talked with the stores managers and workers, so they knew about OSM. They posted stickers so people knew that they were mapped online. And well, this was a once used and only used methodology that makes a lot of tools that we had never had the opportunity to use before. So it was a very interesting experience. And I guess that concludes the small portion of my presentation on how to approach community development and how to use mapping as support, as a support for our community's development. We always need to consider the needs. It's very interesting to always map online, but it's, like I said before, it's necessary to always consider who is living in the territories and the places that we are mapping. So I really thank you for your attention. I look forward to seeing your comments in the chat. And nothing. Thank you again for facilitating the sessions. Have an official letter from local authority to go for mapping in a certain area. I suggest that youth mappers could be introduced within their localities too. Yeah, yes, I do. I don't know if you're in touch with Salma, with the local community in Tanzania. I guess you are because you received the invitation. But I think the letter from youth mappers and the help from youth mappers in general can be very effective to navigate the issues with bureaucratic and documentation needed for these activities. So I agree. And Ashok, from where did you get the financial support? Are these projects sponsored by YouthMappers? Yes, they are. Most of the projects are sponsored by YouthMappers or by another international organization. So we make contacts. I think the YouthMappers is a very good platform to meet other people in the industry. So we've met people with the Geographic Association in Latin America. So that's a regional organization. We met people in universities abroad. And we're always looking for opportunities to share our knowledge. That's how we got the opportunity to go to Guatemala or go to Colombia. And most of the funding is usually used for, let's say, printing or local transportation. What else? Food. When you go on a field trip, it's necessary to have the food. So I think that if you are a shock, if you if you know the regional ambassador in your country or based in the region that you are, you should get in touch with them because they know what the process is for requesting funds, so you can make a budget proposal for the needs of your chapter. There are many questions. Roman Baltasar, okay. From Tanzania, in the chapter of College of Business Education in Dar es Salaam, what are the challenges you encounter when you do mapping in some areas and awareness of people in some colleges? So I think the challenges in some areas can be very similar. I'm sorry if I'm going over the time, Ibrahim. Am I going over the time?
Yes, yes. Just try to round up with this.
Okay, sorry. Yeah, so the problems in some areas is that people aren't as open to mapping. They don't get why you would be mapping their places. And I think it's very important to communicate in a clear way to them the importance of having cities in a map. And yeah, some people aren't as receptive in colleges to open mapping, but it's you need to have a knowledge of what their interests are so you know how to present youth mappers in a way that they are attracted to, in a communicative way or in a very visual manner. I can answer more in the chat if you want.
Thank you so much. I just want to add in the area of the challenges. For instance, if you want to embark on community projects, some of the challenges you normally encounter. This is an experience to me during the 2021 YouthMappers Power Grid Mapping. We were selected to map Lunge, one of the towns in Sierra Leone. And of course, some of the challenges we encounter was the knowledge of the local community or the stakeholders about geospatial is very slim or is very small. So when they saw us moving around with our phone, capturing streets using mapillary, they were frightened. They were like this: who are these people? Are they here to figure out some of our information? Are they here to harm us? So they were threatened. They called us and we explained to them the importance of this community project, some of the benefits it has in the various people around the community. So involving community project, there are lots of challenges from stakeholders, the road network. Sometimes you have to do a project in the villages, the rural areas. So trying to access that area is very difficult. So this is just an experience I've encountered so far, especially when involving in community projects. Yeah. Yes, Maya, do you have any other thing to say again?
No, I don't think so. I'm writing on the chat. Is that okay?
All right. Thank you so much for
Thank
this
you.
wonderful. Can we please give a reaction? Wow, that's wonderful. Of course, we learned a lot from this presentation. So being a youth mapper or being a youth, you have a role to play in developing a community, either in geospatial, either in leadership, either in engaging some sustainable activities. So she has clearly identified some of the activities she has involved in developing various communities. And I'm sure we all that's present here today, we are going to follow that to make sure that we clean our community, we develop some areas we think are important in various communities. Thank you, Maya, for this wonderful presentation. Move to another segment of this training. Thanks to the participant. All right, we'll be welcoming our next facilitator for today's training. Of course, ladies and gentlemen, permit me to introduce this young and dynamic individual. Of course, before going to the introduction proper on his profile, I would like to give my personal experience with this young man. Of course, we met during the 2023 Mappers Leadership Fellow Summit in Jamaica, and coincidentally, we were in the same cohort that is activating the same theme, activating youth leadership. We learned from each other, and it was a pleasure actually learning from this young man. Yes, and let me just share a funny, you know, um, incident between myself and the guy. During that time, I was not involved in OSM mapping, so there is a statistics you can compare individuals, to see. So when he entered his username, I entered my username. We compare each other. He defeated me hands down. So since that time, I started learning from him. You know, so I'm sure also today we are going to learn from this individual, and I'm always honored to work with him. So going proper now to his profile, Victor. Of course, I can only pronounce the the first name, so please pardon me. My apologies for that. Victor is an ambitious and driven student at the Federal University of Technology. Okore, specializing in remote sensing and geoscience information system. With notable leadership achievements, Victor has excelled as a vice president and the president of YouthMappers at FUTA, that is Federal University of Technology in Akura, inspiring fellow students to actively engage in mapping and drive positive change in their communities. Over the span of 4 years, Victor has made significant contributions to OpenStreetMap, showcasing his expertise in GIS and unwavering commitment to make a difference. He possesses a wealth of experience in both remote and field contribution to OSM and has played a key role in supervising GIS fieldwork projects across various organizations. Victor's technical proficiency extends to front-end development and demonstrated through his involvement in creating user-friendly GIS development, demonstrate through his GIS conferences, websites that advanced geospatial technology across Africa. Notably, he was selected as a HOT-USM data quality intern in 2020 and actively contributes to the HOT-USM data quality network for the Western and Northern African Hub, HOT-USM Global Validator, and HOT-USM Training and Working Group. Guided by his visionary leadership and passion for empowering the youth, Victor envisioned a future where young individuals are actively involved in their communities, voicing their opinions and driving change through mapping. He aspired to inspire others, fostering a generation that's leveraging mapping as a powerful tool to shape a better world. Ladies and gentlemen, I have the single honor to welcome our facilitator for today's training. Of course, I like a phrase here, aspire to inspire others. It's a very nice one. So, can we please welcome Victor, Youth Mappers Regional Ambassador based in Nigeria? Thank you.
Yes, yeah, can you hear me clearly? So, I'm currently the YouthMappers Regional Ambassador for Global Technical Support. So today, basically, we're talking on advanced mapping tool, that's QGIS as well, and remote sensing and satellite imagery analysis. Practically, like, there is no really like a demo in this kind of presentation, but it should just give you like foreknowledge or basic knowledge about some advanced tool present in the QGIS environment that you could actually use to do some analysis. Yeah, majorly remote sensing analysis, and also to be able to analyze your GIS data. All right. So I think Ibrahim has said a lot much about me. I don't really need to say anything much again. Thank you very much. Okay, so I'll just go right up in. All right, so today we're just looking at the remote sensing, and majorly we're focusing on the satellite imagery. And then we'll also be looking at the whole thing about QGIS and also advanced tools available on QGIS. Then we'll also be focusing on satellite imagery analysis with QGIS. And I think there are some links that will also be available on this slide that you can use to like do personal learning, or probably like talks more about everything that we're going to go through today. If they you can access that once the presentation slide is shared. All right, so remote sensing. I think this is something that Erick talked about. So remote sensing basically is seen as a data collection. I call it a data collection tool, basically. So it is a process of collecting information about objects or area from a distance, typically from satellites, aircraft, or drones. So basically, remote sensing is just about getting information about a particular object without having contact with that particular object. And so this technology requires specific sensors. So the thing is, we have satellites, different satellites, and their respective sensors placed under the satellite. So majorly, it is not the satellite that collects the data. It is the sensors that actually like collects this data that we actually need. So we have two different types of sensors that are attached to different satellites, most especially apart from the communication satellites, basically. So we have the passive and the active. So a quick understanding about the meaning of passive and active. So for passive, passive actually like depends on the sun for source of energy. That is, it does not have its own source of energy to be able to collect information about a particular object. But the active sensors actually has its own source of energy. And we could actually look at active producing its own energy to collect the information without having to depend on any other source. So majorly your passive sensor depends on the sun. So the sun serves as the source of energy for the passive sensor. All right, so satellite imagery basically, so it's a critical component of remote sensing, and this is involved in capturing images of the Earth's surface from space using specialized sensors and cameras on satellites. Yeah, so one of these satellites images that we have the Landsat, we have MODIS, we have Sentinel, we have like tons of them. And basically, what this particular satellite does is it actually captures images of the Earth. This satellite are actually placed at different orbits, like the sun-synchronous orbit, the geos, and all other orbits, basically to collect information of the Earth. So what they do is it captures images of the Earth, basically, and this is what we regard as the satellite imagery. All right, so satellite imagery can vary in several ways, including in terms of spatial resolution. So I'm just going to talk extensively on this particular feature. So different satellite imagery has different spatial resolution. For example, your Landsat actually has a spatial resolution of 30 meters. That is the pixel size of that particular satellite imagery. This is like the amount of objects that you can be able to identify in your satellite imagery in a particular pixel. Yeah, so your Sentinel majorly has some respective band has close to like I think 10 meter resolutions. You have Iconos. Iconos has like a good spatial resolution. I think maybe close to like 2 meter or 1, if I can remember vividly. So all of these satellite imagery, like they vary in spatial resolution, different spatial resolution. So you as a GIS analyst or you as a YouthMapper, if you really want to make use of satellite imagery to do an analysis, you need to consider the spatial resolution of that satellite imagery. And basically, what determines the kind of spatial resolution you're going to use is the type of analysis that you want to do. Yes. So the higher your spatial resolution, the higher you are able to capture information more detailed. All right. Then also you have your spectral bands. So different satellite imagery has different satellites basically has different spectral bands. You have the multispectral satellite images, you have the hyperspectral satellite images. So the difference between them is your spectral satellite images just have some range of bands. Maybe you add have the visible region. The visible region consists of your blue, red, green, and also have the near infrared, that's the IR, and also some part of the microwave and radio wave. Or your hyperspectral satellite images or hyperspectral satellites or hyperspectral sensors, basically they have multiple bands. That is, in the visible region you can have more than you can have close to like 100 plus bands within the visible region, that is between the blue, red, green. So in your blue region you can have like close to like 50 bands in your blue region, that is different color, different kind of different shades of blue. You understand, in that sense. And with this particular satellite image that is produced from hyperspectral remote sensing, you get to have detailed, good color of your objects in particular, because if you look at the multispectral, you might not really have like a perfect color. You might not really see the color very, very well. But with hyperspectral, you're able to see the color like different. Now we have our objects are in different shades of color. Your vegetation is in different shades of color depending on the current the eldiness of that vegetation. But with hyperspectral image sensing, you are able to detailedly identify different shades of vegetation with the hyperspectral satellite images. Yeah. Then also the temporal resolution. So temporal resolution is just based on the time taken for a satellite to actually like cover a particular area. At least so you could see like some satellites really like takes like maybe like 16 days. I think Landsat takes like 16 days or something like that to come back to a particular area. Then you have some satellite that really like just take like a day or two to take to collect images in that particular area. So your temporal resolution really also what matters. Then the application specific characteristics, yes. So all of these satellites images, it is best that you use some for some specific application. It is best that you use some for some specific application. So maybe you want to for example, maybe you want to like map a particular farm to try to identify the eldiness of the vegetation in that particular farm. You might, if that particular farm is not very, very big, maybe just like maybe like 1 kilometer or 2 kilometer, it's expected that you use a good satellite imaging with a good high spatial resolution and high spectral band, so that you'll be able to differentiate areas you'll be able to differentiate vegetation areas that has, or maybe that has issue, or maybe in their elderliness and every other thing, be able to like differentiate, okay, this particular area is suffering from this particular this particular area is very elderly, be able to identify all of those things and take productive measures immediately. So those are basically the ways we could actually like that defines different satellite images: your spatial resolution, spectral bands, your temporal resolutions, and your application specific characteristics. Yeah, I'll move to the next slide. All right, so this is samples of these satellite images. So basically, these images are taken from by NASA, and also some of them were also collected from your Google Earth. So your Google Earth engine, Google Earth actually has their own satellites, and you can see different buildings. You can see right here, you can see different buildings, different vegetation area. Here you can see your sea, water, and all of those things. So all of these particular features can be viewed with different set of satellite images. Right. So we'll go right up to QGIS. Yes. So what is QGIS basically? So QGIS basically is an open source software that is used to do a lot of GIS analysis. Yeah. So some background about QGIS. So QGIS is like an official product of the OSGO. So that is the Open Source Geospatial Foundation. So they are the one that actually like contributes to the building of QGIS. And I think at different years or different or respective month or interval, they tend to like update this particular application. They tend to update this particular software. So how they do that is set of developers that are committed to this particular foundation actually meet in specific countries, and what they do is they just come together and try to like write some codes and make the software like a better one, maybe add some tools and all of those things. So depending on the particular location where they meet, they kind of like tag the name of the version. Yes. So for example, you could remember, I think that was last year. Oh yeah, I think that was last year. We had the FOSS for G at Italy at Firenze. So you could see that there's a long-term release version right here. That's the QGIS 3.28. So these developers met and they were able to tag that particular software version as QGIS 3.28 Firenze. So all of these names are specific cities in different countries. You can the newest version is the one with 3.32. That's Lima. So that's like the newest version, but the long-term release for now is 3.28. So this QGIS actually works in your Linux environment, Unix, Mac, OS, and Windows. So you can easily download it depending on the kind of OS you are using. And also it supports vector and raster. So we have the QGIS desktop, and we also have the QGIS server. So the server also is like an application that serves your QGIS files to end user applications by the OGC. That's the Open Geospatial Consortium web services like WMS and WFS, basically. So you can serve your QGIS projects on all of those web services. So some key features about the QGIS. So the QGIS have a user-friendly interface. Yes, it's friendly. It's friendly if you like know how to find your way around it. It's friendly. If you look at this picture right here, so this is like how the QGIS looks like. The QGIS environment looks like when you open it up. So also it supports data formats, like your vector data format and your raster data format. I think Erick has talked more about the vector data and the raster data, and also the non-spatial data format. This is very, very key. It supports non-spatial data format. So the difference between your non-spatial data format and your vector and raster is one particular the data, like your vector data and your raster data, is tied to a particular location, that it has like location coordinates. But your non-spatial data does not have location coordinates, but just has information about some particular place. Then also another feature is data editing. So with QGIS, you're able to edit your data easily by doing some digitizing, by doing some splitting, by doing some clipping, and all of those things. So with QGIS, you're able to do all of that. Then also your data visualization. Yes, so for you to be able to view, for example, your satellite imagery in your GIS environment, you can use QGIS to view your satellite images. Yeah, and the satellite images are mainly raster data. They are raster data. Then also you have your geoprocessing and analysis tools. So this geoprocessing and analysis tools is available on QGIS also, where you'll be able to process your data, manipulate your data, so as to get like specific information from there. Then also the QGIS also, like, this is one of the most interesting part of QGIS that I like most, is the plugins aspect. So QGIS actually like allows open developers to build different plugins. Yes, different plugins that run some some algorithms to analyze your data easily. So the plugins area actually has different set of plugins built by different developers, and in this particular place, you really get a lot of tools. Yes, in this particular region where you have all your plugins. Then you have the interoperability. So basically, interoperability basically is just the process of trying to connect maybe two applications together, or rather trying to use different data formats, like different GIS data formats inside your QGIS. So your QGIS is interoperable to be able to use different data formats easily and to be able to connect to other GIS applications too. Then also another feature is your 3D visualization. Yes, so you're able to view your spatial data or your GIS data in 3D formats. Basically, the ones that where for you to be able to do this visualization, your data has to have some set of altitude information so that you'll be able to see the ups and downs, the slopes, the valleys, and all of things and around within a particular region or an area. Yes, so those are the features. Go straight up. So data formats available on QGIS. You have the vector data format, you have the raster data format. Yeah. If you look at this image right here, so if you come to once you open your QGIS, you come to layer and click on add layer. So these are the series of layers that you can add to QGIS. You can add your vector layer, you can add your raster layer, your mesh layer, delimited text layer, and all of those things. Your PostGIS layer, and different kinds of layers that you can see here. So your vector data format is a geospatial data representation method that uses points, lines, and polygons to model your Earth surface. And I think this is one of the most data format that you can find in OSN, your OpenStreetMap. So all of your buildings majorly are in polygon formats. They're in the polygons. It uses the polygon geometry. Your roads uses lines geometry. Your POI, like points of interest, locations of different offices, locations of street lights, and all of those things uses your points geometry. So we actually use the point, line, and polygons geometry to model the Earth surface. So it is used to okay. Then your raster data format is a geospatial data representation method that uses grid of regularly spaced cells or pixels. Yes. So your raster data format mainly is always in pixels. So all of these pixels, as I explained earlier on for the satellite imagery, we have different satellite imagery has different spatial resolutions, and this is actually like based on the kind of pixels that particular satellite imagery has, the size of the pixel basically. So your raster data format actually comprises of different set of pixels that are regularly spaced to represent your Earth surface, and one of it is your satellite imagery. Your satellite imagery is a type of raster data. All right. Then also it can be used to represent information like your elevation. You can elevation in terms of your DEM data, your digital elevation model data, in terms of temperature, in terms of land cover. Yes, in terms of land cover, and also the intensity of reflected light and specific wavelengths, basically. Then also your non-spatial formats. So these are formats that do not inherently contain geospatial information, that do not have coordinates. Some of them is your CSV, that's your command separated values. And for you to be able to add your CSV, you use the add delimited text layer on QGIS. So you can use that to add your CSV or your XLS, your Excel formats, your JPEG, your PNG. Yes, these ones do not have like a particular geospatial information, so they are regarded as the non-spatial format. So if you look at this picture right here, where we have different kind of you have some lines. These lines are representing different routes, and you can see some points now. Yes, these are representing like location of maybe soil sample basically that was kind of like collected when I was trying to view this data set. Then you also have your polygon. So your polygon is always like in terms of like your area, like your area boundary kind of. Yeah, so so that is data formats available on QGIS. All right, so now geoprocessing tools basically. So the QGIS basically focus really like has different kind of geoprocessing tools, and this geoprocessing tools majorly helps in manipulating your spatial data. So a typical geoprocessing operation takes an input data set, performs operation on the data set, and returns results of the operation as an output data set. And some of these particular tools are are majorly your the spatial statistic tools. Yes, these spatial statistic tools are used to explore different spatial patterns and relationship within your GIS data set, that either the vector data set or the raster data set. Then you have some terrain analysis tools. So basically these tools help you to like create like elevation profile, majorly this particular tool is your input data is always your DEM data, your digital elevation model data. So you can use that to kind of like model your slope, the slope of a particular area, the aspect, and the elevation profile of that particular area, and also you can do like your hill shade. Then also another particular tool is your network analysis. Yes, so your network analysis, these tools are basically for routing, analyzing network data. So majorly in this particular tool, you deal majorly with your points data, and your deal with your points data, your line data, and also your polygon data. But majorly you deal with your point and your line data. So your line data can maybe represent your road networks. So you can use the network analysis to kind of do perform some road network analysis, maybe like origin to destination, trying to calculate the time that it's going to take for a particular person to move from this particular location to another location, and all of those things. So all of these processing tools can be accessed on the processing toolbox on QGIS. So once you open your QGIS, by the side, you just easily see your processing toolbox. Yes, your processing toolbox actually has list of different geoprocessing tools that you can use to manipulate your data sets. So some geoprocessing tools that I'm just going to talk about. One of it is your buffer. So what buffer does is create an equal zone around specific features at a specified distance. So for example, maybe I want to actually like model, try to like know the extent of maybe 1 kilometer from a particular point. Maybe for example, I want to use this as an example. Maybe you have a street light represented as points on your GIS environment, and you want to like try to like know the respective features that you want to like do model like a distance from that particular point out. So maybe like you want to do like maybe like 1 kilometer from that particular point, and you want to identify the kind of features that is within 1 kilometer distance of that particular point. You can use your buffer to model that out. Then and also another one is your intersect. Yeah, so the intersect helps you to like create a new layer based on the area of overlap. So when you try to like overlap two layers together, for example, if you look at this picture, this actually depicts how it looks like. So if you really want to like intersect two layers together, so you can use your intersect tool to just when you overlap two layers together to kind of like join them together or something like that, and be able to identify where they join together within the geometry or within the kind of nodes. Yes, yeah, you can use your intersect tool. Then you also have your union. So when this helps you to like merge two layers together into one. Yes. Then you also have your symmetric difference. So creates new layer based on areas of two layers that do not overlap. So you want to like know the difference between layers that do not overlap. You can use your symmetric differences. So all of these geoprocessing tools actually have application area depending on what you want to like come up with, how you want to manipulate your data. Then we also have the clip. Yeah, this cuts a layer based on the boundaries of another layer. So for example, if I have a raster data set, maybe like a satellite image like of the whole of for example, maybe of the whole of Italy, and I also have the boundary layer for this for Firenze city, and I really want to just cut out the raster data, the satellite imagery covering Firenze alone from the whole of Italy. I can easily use the clip tool to just clip out that particular area that I want, the particular area of Firenze. You can clip it out from the whole satellite imagery covering the whole of Italy easily. So your clip tool helps you to do that. Then you also have your difference. I think I've talked about difference to subtract areas of one layer based on overlap of another layer. Then you also have your dissolve tool. Yes, dissolve also is very, very key. One specific key aspect of dissolving is, so for example, so let's say in Nigeria, so Nigeria basically has close to like 36 states, and I have a particular GIS data set that has the boundaries of all the old 36 states. And I don't really need that information. I just need the whole boundary of Nigeria from that data set. With Dissolve 2, you can easily like merge all of those boundaries together to form the whole of Nigeria boundary easily. So your Dissolve 2 helps you to dissolve layer into each other, to merge feature into each other, to be able to have a single layer based with a single layer with common attributes. Yes. So majorly, so these are some of the geoprocessing tools. There are a lot of them. But this is what I'm able to explain more on, basically. Let's go to the next one. All right, so you have your interpolation tool. Most of us would have heard of interpolation. Interpolation is very, very key. in GIS analysis. So several interpolation tool that allows user to estimate values for points with a continuous surface or raster grid based of known data points. So basically what interpolation helps you to do is now it helps you to kind of like generate information about unknown points. So now all you just need to do is you need some sample points, you need known points. So you can use your interpolation tool to be able to generate you can be able to generate different points within your sample points easily. So it will help you to like you use a known data point to generate unknown data points. That's just the whole thing about interpolation basically. If you look at this image here where you have your points and you have some kind of round layer under it. So this is like a result of interpolation. So the points basically are the known data points. So you can use that to generate all other points. So now, if I try to check the attribute table of the layer, the layer here, the results now, you could I could see some how will I put it, some similarities between the information on this point and with that particular layer too easily. So your interpolation just helps you to generate unknown points from known points. So some of the interpolation techniques, we have the inverse distance weighting, that's the IDW, and this is like mostly used. And you can easily access that on your processing toolbox on QGIS. You can see it here under interpolation. You can just easily like search IDW interpolation. It will bring up the tool to be able to like do generate unknown points, unknown data points from your known data points. So basically, this IDW helps us to estimate values at unmeasured locations based on the values of nearby known points. So it uses the nearby known points to generate known points easily. Then you have your TIN interpolation. So your TIN interpolation basically constructs a new network of triangle from input points. You are creating a surface that represents the input data points and their relationship. So basically, it helps you to using your known data points, you can easily like generate like a network of triangles of those particular points just by creating a surface that represents the input data points. I think some of the things that you can generate from this, you can generate like a view of maybe like the 3D view of a particular area using those data points. And also you have your heat map. So your heat map basically helps you to identify clusters, density of point data. So if you look at this particular same information right here, you can see that you have some red color, you have some yellow color, kind of some green color, and you have some blue color also. So your red color basically like depicts that you have you have the density of point data in that particular area is very high, but the density of point data in your blue region shows that that particular place is very the density of point data in that particular place is very low. So it can help you to identify different clusters of information of points data, and this basically will help you in analyzing your GIS data set. For example, if I have a point data of different street lights, maybe within Nigeria, I can easily use the heat map to identify places where you have high density of those where you have more street lights. Yes, using you can use your heat map helps you to like generate such kind of information easily just by representing the difference the density of the points data. Then you also have some interpolation plugins too. Yes, on QGIS you can easily go to the plugins aspect of the QGIS. You can easily access some interpolation plugins built by some developers also to be able to run your interpolation, do your interpolation analysis. Yes, so that's all for interpolation. Then the interesting part is the satellite imagery analysis with QGIS. Yes, some people always say that your QGIS basically focuses more on is very good with your vector data sets. Yes, it is very good with vector data sets. There are sometimes that I make use of the ArcGIS, trying to like convert vector data formats, maybe from a particular format to another format. Sometimes ArcGIS might not really give me like the whole thing I want to see. And one of the best software that I've ever used for vector data sets is your QGIS. So easily your QGIS helps you to convert different vector data formats to another vector data format easily. All right, then also QGIS also is used. We can also use it to analyze your raster data set. So satellite imagery analysis with QGIS. And one of it is image classification. Yes. So as I specifically said earlier on about satellite imagery. So satellite imagery actually comprises of, if you download a satellite imagery basically, it has sets of bands. For example, your Landsat has some sets of bands. It has band 1, band 2, band 3, band 4, and all of those things. Yes. So your QGIS can help you to create like a composite band. That is, the composite band basically helps you to join all of these bands together into one particular layer, and you can easily like manipulate these bands. You can change within the RGB, within the red window, the blue and the red. You can input all of these bands to. You can change. You can put different bands into all of this window, because of basically the computer really like display everything in RGB. Yes, all of your colors basically. So you can put some of these bands in those particular window using your QGIS just to kind of like view your information perfectly well. So so your image classification, we have two types of image classification. We have the supervised classification and the unsupervised classification. So your supervised classification, the process begins with the set of training data where each data point is associated with a known class label. So one thing about supervised classification is that for you to be able to do supervised classification on a satellite imagery, you need to have some set of training data sets. That is, you need to have data sets that shows, okay, this particular location is representing water, this particular place is representing built up area, this particular place is representing vegetation, this particular place is representing your soil and other classes. So you need a trained data set to be able to run a supervised classification. So after you have done your old composite, after you have merged your old composite bands, yeah, for example, here, and you can now use this training data, your training data to run a supervised classification for that particular area. So what it does is it will now help you to classify your imagery in a better format, where you'll be able to identify that, okay, this particular class, this particular area is vegetation, this particular place is built up area, this particular place is water perfectly well. So if you look at this particular example here below, you can see some classification, you can see some different class, you can see the unclassified, you can see water, built up, vegetation, soil. So if you look at this, the results here, you can see where you have your green, your blue. So that your blue area is representing the water class. So any within that particular within your results, any particular place where you see blue represents water. So this is depending on the class labels that you have used. Also, you can see your green represents vegetation, the yellow represents soil, then the red represents built up areas. Yes, red represents built up areas. So this is how you can be able to like classify your satellite imaging easily for identification by using the supervised classification. So you can use QGIS to do that. Then also you can do the unsupervised classification. So now there is no need for prior knowledge about class label. The algorithm groups data point based on the inherent patterns, similarities, or clusters within the data. So for your unsupervised classification, there's no need to have information about known class label or trained or have like a trained data basically. So what the unsupervised classification, the algorithms that perform the unsupervised classification actually does generate different class label just by the similarities between this the spectral information on the raster data, the patterns, the clusters, and all of those things. So it just generates these classification labels for you, and you'll be able to run your you'll be able to classify your satellite imagery even in this same format, basically. So one of the major tools that I've actually like used, and I know that is very common nowadays on QGIS that runs the whole satellite and the whole image classification, is your SCP. So SCP is a plugin on QGIS that does this whole classification perfectly well. That's the semi-automatic classification plugin. That's the SCP. So basically, this SCP, you can easily just check it out on QGIS. It has sometimes at first when you open it up, you might not really like understand the whole thing that is going on around it. But you can easily just click on the help tab. It will take you to the manual where you can be able to understand how to use this plugin effectively. So this plugin will help you to do your classification from ground up, from trying to merge all of your bands together into a composite band, then trying to pick all your training samples, and also to producing a classified result of your satellite imagery easily. So it helps you to do the supervised classification and also the unsupervised classification easily, depending on the satellite imagery that you depending on the respective bands that you have assigned to, that you have uploaded into the plugin. So another thing for satellite imagery analysis is the remote sensing indices. Yes. So this is another particular way of analyzing your satellite imagery. Remote sensing indices, basically, these are mathematical expression or formula used to extract specific information from remote sensing data, particularly multispectral and hyperspectral imagery. Yes. So your remote sensing indices basically they are just sets of mathematical expression. What what these indices do is it helps you to manipulate different bands together. Helps you to kind of like create manipulate different bands together. Maybe like minusing one particular band from another particular band to produce a new layer of band basically. So for they are designed to enhance or highlight certain features, properties, phenomena in the data, making them valuable tools for wide range of application in agriculture, forestry, environmental monitoring, and more. So one of these remote sensing, this is your normalized different vegetation index. So with your NDVI, with this simple NDVI, I can easily like understand I can easily understand the healthiness of vegetation within a particular area. All I just need to do is to get the respective bands, spectral bands of that particular area, and just try and do some manipulation just try and use do some manipulations with those bands. So all of these remote sensing indices has different formulas, like your NDVI for when you're using Landsat 8 satellite imagery. You can the NDVI formula for using Landsat 8, you have your band 5 minus band 4 divided by band 5 plus band 4. That is your infrared band, your near infrared minus your red infrared divided by your near infrared plus your red infrared. So well, divided by your near infrared plus your red band, basically. So you can use that to be able to identify how do I put it, the healthiness of vegetation within a particular area. For example, if you can look at this particular image, this is just NDVI showing this is an NDVI map for 2009 and 2020. So you can easily use your remote sensing indices to just kind of see the difference that has happened over time. For example, if you look at the NDVI map for 2020, you can see that you have more of this red region. So basically, this is your red region. Actually, like what the respective features that you can have within your red region. This that has low values basically is your built up area, places that are not that do not have vegetation. Yes, basically. So you can see that from within 2009 and 2020, this red region, this red areas has actually increased over time. That is, it shows that in that particular area, you've had like more of like built up, you have more of deforestation of that of vegetation areas within this particular boundary. So you can use your remote sensing indices to identify all of these changes, temporal changes basically within different years. You can also use the enhanced vegetation index. One of the difference between the NDVI and the EVI is that the enhanced vegetation index helps you to mitigate some kind of like effect from the soil background from that particular data, from the background of the soil background of the data. So the soil also like contributes to some of the information that you can get from your your red band or your near infrared. So in order to mitigate such kind of effects when trying to like do your vegetation indices, you can use your enhanced vegetation index. So it basically just enhances your NDVI perfectly well to have good information about how vegetation has occurred within your area. Then you also have the soil adjusted vegetation index, the SAVI, also does some of the same thing too. You also have the LST, that is your land surface temperature. So one interesting thing is from like there was one time I was trying to learning about remote sensing indices, and then one of my lecturers just said that you can easily like generate temperature information just from your satellite image. I was just wondering that how will you be able to generate like temperature from your satellite image? It is, and when we started the whole remote sensing this. Sorry. So when we started the whole remote sensing indices process for the land surface temperature, all we just did was we just there was a particular formula that we just followed, and this formula basically was collecting information about the different set of bands that we just multiply together, divide together to be able to arrive in our to be able to get our temperature easily, like just like that. You're not having to even go to the field to just measure the temperature of that particular area. So with satellite imagery, you can really do a lot of things. The bands actually like they're full of information, and you can easily like get this information just by using your remote sensing indices easily. So you also have your normalized different water index, so to be able to identify areas that are full of water, areas that are full of less water. So some of the tools available on QGIS that will help you to do this remote sensing indices is your raster calculator. So majorly your raster calculator helps you to manipulate your band. So with the raster calculator, you can easily like do a lot of formulas just by manipulating within your bands. You can see this example here around this particular place. So this is an example of NDVI calculation when I'm minusing the band 5 minus band 4 divided by band 5 plus band 4 to be able to be able to get your information. Then you also have some plugins too on QGIS that helps you to do your remote sensing indices like the VDIP. So you can easily check that out. Basically, this plugin focuses on the vegetation indices alone, basically. So you can easily check that out. So that is all about remote sensing indices. Like you can easily play around with your satellite imagery, like easily just by manipulating your bands easily. Yes. So some of the resources, these are links to resources that could help you to get started on how to use some of the some of what I've just discussed now, like your image classification, then the SCP too. So this SCP, once you click on this particular link, it will show you different it will show you the process of trying to using SCP to do your supervised classification or unsupervised classification. Then these are some links to your geoprocessing tools to on QGIS, and also 3D visualization on QGIS basically. So there are also tons of different YouTube tutorials available that you can easily just jump on, and they will easily just explain the whole flow about how to use QGIS to use all of these tools basically. Uh, so thank you very much. So if there's any question, I can just take in right now. Thank you.
Participants or facilitators sharing their experience. We're now going straight to the panel discussion. Are you seeing my screen? Not yet. Okay.
No, no, we're not.
Okay. All right. Give me some time. Okay. All right. Okay, yeah, it is now. And permit me to share my screen. Okay, you're seeing my screen, all right? Are you all
Yes.
seeing my? All right, thank you so much. Thank you to our valuable participants for the time. We deeply appreciate you all. And we are now moving to the final segment of the training, a panel discussion in order for us to address this theme, geospatial skills in diverse industry and addressing global challenge. Of course, without wasting time, we're going to start proper. And I'm your moderator, Ibrahim Abdula, Kargbo, YouthMappers Regional Ambassador based in Sweden. For the speaker one, we'll be having Maya Lovo from Mexico, YouthMappers Regional Ambassador. So let's start. For Maya, she'll be discussing the application of geospatial skills in addressing social and environmental issues. She'll discuss mega projects that affect protected areas, gender studies, accessibility, and violence. For speaker two, Victor will be discussing using geospatial skills in addressing global challenges. Primarily, he will be focusing on highlighting global impact of geospatial skills in addressing challenges like climate change, public health, and disaster response. We will also discuss on geospatial data aid in mitigating these challenges in a large scale. And for those speaker Nishan, he'll be discussing on the importance of geospatial skills in diverse industry. We'll dive into the significance of geospatial skills in natural resources management, conservation, and disaster risk reduction. And for the last speaker, Erick, he will emphasize on the critical role of geospatial skills in industries such as agriculture, transportation, and urban planning. He will share practical example of how these skills can contribute to efficiency and informed decision making. So without wasting time, we're going to start with our first speaker. Ladies and gentlemen, permit me to welcome Maya on stage to deliberate on this important area. Let's welcome her, please.
Hi again. So it's only a 5-minute intervention. I'll try to be very brief
Okay.
and cover all of the discussion points for my presentation. I wanted to focus on the application of GIS and cartography in addressing social and environmental issues and present some examples besides the one that I already mentioned in my previous presentation that have used in some way or another open data and open geographic information. So I'll share some links Oh, can I share instead of you, Ibrahim?
Okay.
Sorry. Okay, thank you. Just so I can have a visual help. Okay. So I was mentioning, it's in the agenda that some of the projects I've worked on are related to urban planning, to gender, to migration, and I wanted to present this one first. This is an ongoing mapping project, and we are doing with my chapter in Mexico City, but also we have organized with another collective of women who use geography, and also with a regional organization of women who use OSM. So it's a very huge cooperation, collaboration. And what we've done in the framework of month-long mapathon is that we wanted to discuss what public space, public safe space means, and it's very difficult to do so only by mapping something. So what we did instead of only mapping the municipality that we were interested in was identify elements and things that make it safer for women to live in that place. And especially in Mexico City, that's a huge city in the country. There are things in the urban infrastructure that influence the experience and the notion of women with their surroundings. And what we did was that after a participatory cartography workshop we had in the municipality with women who lived in it. We organized a project with the task manager of QGIS, and we decided to map two elements that were very important. So those were the lighting pole, like public lights on the street, and cameras, vigilance, because we think those two things are very important when thinking about safety. So we have this project, it's ongoing. We are closing it in 1 or 2 months, I think. And we are mapping with images from Mapillary because we need to know what the surroundings look like and have a better idea of the streets. And the result so far has been great. When sorry, I'm not logged in. Well, but when we first started the project in this place, you can see how huge the area is. It's all of this. There were only 150 public lighting places, and now, if we go to Overpass, that's another tool that we can use to track our edits in OSM, we can see that we have almost 300 nodes of streetlamps. And it impacts a lot on how we can analyze the information and have a better idea of the perception of violence and safety for women in Coajimalpa. That's the municipality we chose. Besides that, um, another project that I wanted to share with you is a personal one. So I did this map that we can see here. Okay, it's very important to me to clarify that this is a map that I made because in the country that I lived for many years, in El Salvador, there's no available data online, and a lot of projects are happening and are putting in danger the protected natural areas of the country. So I had to download the shape files of each natural area that you can see here. And by monitoring newspapers and other media online, since they are the only source of information about these kinds of things and events, I found different projects that are affecting the areas that are supposed to be protected in the country. So, for example, here in the top right at the north of the country, there is contamination for a mine that's opening in Guatemala, but it's also affecting a lake in El Salvador. And also in the coast, there are people who are being kicked out of their homes to make a park. So it's very interesting to have this as a tool, not only of mapping in general, but to recognize the issues that happen and to protest in some ways the um, the actions that are affecting our environment and our communities. And I think I've run out of time. Please
Yeah.
let me know if I have. Yeah. But those are the two things that I think are very important to highlight in my presentation. And you can contact me after, maybe through my LinkedIn. I can share it here.
so we can talk more about the methodology I used. But thank you for the space.
Thank you so much. Wow, it's very great. Of course, these two projects you shared to us, they've actually inspired us. Thank you so much. Without wasting time, we go straight to our next panelist. Permit me to share my screen. Yes, thank you so much, Maya, for giving us an insight in mega projects that affect protected areas, gender studies, and accessibility and violence as well. We've learned from that. Ladies and gentlemen, let's welcome Mr. Victor, YouthMappers Ambassador based in Nigeria, to share his insights on using geospatial skills to address global challenges, especially climate change, public health, and disaster response. Let's welcome Victor from Nigeria. Thank you.
Okay. All right. So thank you very much. So practically, I'll just kind of talk some like a bit about how you could use geospatial skills to actually like for climate change, for disaster response, and all of those things. So basically, there's a wide range of geospatial skills that is needed if for those that really want to like major in GIS, for those that want to major in manipulating remote sensing data sets and all of those things, and also you as a youth mapper. So we are not just mapping buildings, not just um, mapping roads or mapping waterways and all of those things. So also trying to be able to use this data set to kind of make different maps that can be used for decision making by different agencies and all of those things. So first thing, I'm going to talk from standpoint of disaster response. We can actually see that there are there are a lot of marathons that is going on currently, basically immensely to the OSM database to kind of make available of this geospatial data sets that can be used to analyze or to actually like prepare to actually make like prediction to make some like some prediction analysis about maybe like disaster that is coming up, or rather a disaster that has happened, to kind of like give like prior knowledge about disaster and all of those things. So it is very important that as a youth mapper, you actually like grow, you actually like build yourself in geospatial skills, starting from mapping to using all of those geoprocessing tools that I've talked about, to be able to manipulate raster data set like your satellite images and all of these things. So we actually have some available free data sets. For example, your satellite images, you see, they are still free to some extent. Like for example, your Landsat. So your Landsat, basically, why we actually have Landsat is Landsat basically is focusing on as a particular goal, like the Landsat is satellite imagery. So basically, the Landsat satellite image, the Landsat program actually consists of series of Earth observing satellite missions jointly managed by NASA and US Geologic Survey. So basically, they have been collecting this data to actually like improve and understand our Earth, understand the Earth's its natural resources and its dynamic processes. And that is why you will notice that the Landsat data is like consistent, is only like you get to download different Landsat images maybe after 16 days or something like that. Yes, so basically they are using this particular imagery or data sets to actually like understand the Earth, to know how the Earth is changing over time, to understand its natural resources, to be able to understand the dynamic processes that is occurring within the Earth. So the aspect of analyzing these satellite images, actually as a youth member, you would need to actually like gain some specific skills on how to analyze all of these satellite images in the aspect of classification, in the aspect of using your remote sensing indices to be able to be able to record or to be able to model these dynamic processes within the Earth using your satellite images. So it's important that you have all of these like all of these particular tools to be able to analyze your data sets. Then also even other majorly other satellite images that you can see that are available to download, they are actually focusing on specific goal. Yes. Then also one interesting thing that you can really use to be able to for disaster responses for a particular like large area, you can usually use like Google Earth Engine Yes, I use Google Earth Engine for those of us that are very good in with coding, maybe like with JavaScript and also Python. You can easily like download all of these Landsat images like easily and just like run analysis over a large area of land. So with your results, you can be able to mitigate some of the know the causes of some of the climate change over a vast area of land, know the reason, know how deforestation is occurring over time, know how vegetation is reducing, know how built up area is like increasing in a particular area. Maybe you're able to even to monitor, even to do like real time monitoring. Maybe trying to like monitor the coastal region of the earth, or maybe like monitoring the how water how this in the sea has extended into the land and all of those things. So you can easily use all of these data sets to you can easily
Thank you so much.
All of this, analyze these data sets by using Google Earth Engine easily. I
Yes,
think that's what I can say in that sense. Yeah.
can you also use HOT Task Manager to respond to disaster climate change project?
Yes, definitely. Yes.
Okay.
Yes, definitely. We have a taxi manager that actually like addresses specific disaster issues, basically. So all of those projects are not just created for fun. Basically, they are created to actually to address a particular challenge, to address a particular problem, be it environmental issues or maybe like flooding and all of those things. So all of those projects are actually focusing on they focus on specific environmental issues, basically. So just contributing immensely into those projects, we actually make the organizers or those that created the project to be able to access enough data sets for to analyze or to predict or analyze that particular area in respect to the issue they are trying to solve. Yeah.
All right. Thank you so much, Mr. Victor, for enlightening us some of the areas or some of the ways to address challenges when it comes to climate change, public health, and disaster response. Like Google Earth Engine is one, HOT, QGIS. Thank you so much. Without wasting time, let's welcome also another speaker. Is Nishan with us? Is Nishan with us? All right, let's welcome Mr. Erick Tamba, YouthMappers Regional Ambassador based in Tanzania, to share an insights on the importance of geospatial skills, especially in various industries such as agriculture, transportation, and urban planning. Mr. Eric,
Hi, Ibrahim, and hi,
thank you so
everyone.
much. Thank you so much for
Yep,
being here. So the floor is open now
thank
for
you.
you. Thank you.
Okay, so I will share this discussion
All
in
right,
a
so
nutshell,
you share the
probably
screen.
like 2 minutes. No, 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 it's okay.
Okay.
I'll just speak for almost 2 minutes
Okay.
then. Yeah, so I'll summarize this talk, in emphasizing the critical role of geospatial skills. It's really important to, deploy GIS skills that I actually mentioned in this webinar in terms of putting it as a tool in problem solving. So just before I go, sharing how those geospatial skills have been used in several fields. As a GIS enthusiast, you just have to, develop a passion with several core skills, I would say. So affection with your computer. That's one of the things that I normally emphasize. YouthMappers chapters here in Tanzania. You should love your computer. You should love all those, applications. You should interact with them more oftenly. But again, you should also have some additional skills to that in terms of mathematics, like statistical analysis. Victor has just mentioned some, spatial analysis procedures. So you need to you have those, statistical understanding on data, and also you should have, the geographical feeling of your community, and that's from Maya, understanding different attributes from your communities when you can create big ideas, and represent them to be adopted or outscaled in the rest of the world. So in terms of agriculture, transport, urban planning, for instance, when taking GIS as a tool in terms of urban planning, it could help, determine how settlement patterns are. It could also help, the information could help, help the government in terms of all the local government in terms of tax collection. I got this from an inspirational presentation from OSM Uganda, and I really like the way they helped out businesses, be on the map. But again, the data could be used by the local government in terms of analyzing who are street vendors, who are big business owners, to create great environment for them to do their activities. So I would love to share more in terms of links and everything in our group. So back to you, Ibrahim. Thank you so much.
Yeah, thank you so much, Mr. Eric, for highlighting these important areas. It's very unfortunate we don't have Nishan, you know. But let me share also an experience when it comes to the importance of geospatial skills. When it comes to geospatial skills, there was a student in Unimark, one of the universities in Sierra Leone, a law student. Of course, he used geospatial information, like the example Mr. Eric gave is similar to this. What he did, he organized, on that time he was the president for the chapters in his university. So he organized a project to map all the local ports within Makini, one of the towns in Sierra Leone, and the project went well. So this shows how geospatial information is important, not only in those people using maps, but in all businesses, be it law firm, be it companies, be it an IT firm, geospatial information is very important because people need to access your location. And besides now, most people are using maps to access areas. So they want to sell information, some of the products or some of the things your business does. So these are some insights on the importance of geospatial information. So I want to thank everyone. So now it's high time now we open the floor for participants to ask questions. But before doing that, I don't know if Nishan from Nepal is with us. Okay, right, we'll proceed. Thank you, Mr. Victor. Thank you, Mr. Eric. Thank you, Ms. Maya Lovo, for sharing insights when it comes to addressing global challenges using geospatial skills and the importance of geospatial skills in various sectors. So thank you. Now we open the floor to the participants to ask questions.